Hello and welcome to the official presentation of Hurricane. Hurricane is an advanced physics simulation suite integrated directly into Blender. Its main goal is to unify fluid calculations using DDR solver and simulations for cloth, sand, snow, and soft bodies using the XPBD method into a single, highly optimized environment. The amazing thing about the solver is its massive multitasking potential. It's a unique ecosystem where you can smoothly and simultaneously mix all types of physics and interactions in the same scene. In this first tutorial, we will take our first steps by establishing the general foundations of Hurricane. You will learn the standard workflow and see how it is possible to mix and interact fluid and cloth simultaneously with the same simulation using specific tools like vertex spinning or deformable surface interaction. Also remember that as a Hurricane user, you will have access to an interactive web portal where all tutorials will be saved and explained step by step. This will greatly facilitate your learning, grant you quick access to Hurricane resources, and even provide the exact scene used in each tutorial for download, so you can practice at your own pace from the official BeFX Studios website. Let's begin. We will start by clicking the Start a New Simulation button in the Hurricane panel. Once clicked, you will see that all the add-ons options are immediately enabled, and the default collider floor is generated in the scene. To work more comfortably and keep the viewport clean, we will go to the collider module and disable the floor's visibility. Now, we will add a simple plane. We will subdivide it 40 times to have enough resolution to capture details in the cloth. Once done, we'll go to the Add Emitter option, where we have several presets available to assign a specific behavior to our emitter, such as fluids, sand, soft bodies, or cloth. And in our case, we will select the cloth preset. By selecting any of these presets, Hurricane automatically configures both the emitter settings and the internal constraints to make sure the particle behavior is appropriate for that type of physics. Before moving forward, it's key to understand the core workflow in Hurricane. The entire engine runs on particles, which are the heart of the solver. Although you can go to the surface panel at any time to generate a mesh and view the actual surface, it is generally much more comfortable and efficient to work directly with particles. For instance, meshing fluids in real time makes the viewport heavy and slows down your simulation, so it's best to design with particles first and enable the mesh only at the end. The only exceptions are cloth or soft bodies. Since their meshes are lightweight, it is completely possible to enable them from the start and it won't cause any performance issues, giving you better visual feedback. Just keep in mind that we will often need to click the refresh button in the surface panel to ensure the updated particle data is correctly applied to the visual mesh. Once this workflow is clear, let's get back to the practical simulation. For convenience, we hide the emitter and play the simulation. We will see how the cloth falls into the void due to gravity. To prevent this and keep it suspended, we'll explain now how to use the pin tool to hold the cloth in mid-air. First, we clear the cache to avoid having the simulation particles in the viewport. We enable the emitter's visibility again and enter edit mode. You'll notice that by default, the emitter has a geometry nodes modifier enabled. To better visualize and select the vertices on our mesh, we temporarily disable this modifier from Hurricane's emitter list. With the mesh visible, we select the four corner vertices, go to the pin section in Hurricane, and click the Per Island option. This will automatically create an empty object at each selected vertex. These vertices are now pinned, and each empty acts as an independent controller. If we wanted to, we could move them to displace or animate the cloth from those specific points. In Hurricane, everything you play in the viewport is stored in a cache. This means that any change you make, like moving one of the empties, will cause the cache to store that cloth behavior, and when you replay it in the viewport, you will see your cached result. We must use the Clear Cache button to clear it if we want to continue working on the simulation. We clear the cache, and when we play the simulation again, you'll see that the cloth is hanging perfectly stably in midair. Before we move on, let's take a quick look at our emitter's constraints panel. Here, we control the internal physical limits of the cloth, such as stretch, shear, bending, and compression properties. For example, if we modify the bending or compression values and simulate again, you will see how the stiffness or elasticity of the cloth changes drastically. While we won't deep dive into these properties today, it is important to know that this is where real cloth's behavior and wrinkles are determined. Now we will add an emitter using the sphere volume option, included in Hurricane. Although we will use it as fluid in this case, there's actually no need to configure anything. By default, any new emitter starts configured as a fluid emitter. Here is a key, important detail. In Hurricane, each emitter has its own solver assigned to it. This means that in the particles section, we can independently choose whether its behavior should be fluid or granular. If we take a quick look at the solver's properties on screen, you'll see that the fluid emitter uses the DDR solver, while the cloth emitter, we created earlier, uses a different solver based on PBD multi-step. But let's focus back on our fluid emitter and its properties. Depending on the type of simulation we want, such as water, sand, and other physical types, we'll need to adjust certain emitter values. Among these are the mode setting, which determines how spawn points are distributed, as well as particle size or mass. In this particular example, we'll have to adjust the mass attribute, so the fluid and the cloth can interact correctly. We'll look at this technical section in more detail later in this tutorial. This allows us to generate a constant spherical volume of water particles that will fall directly onto the cloth. If we play the simulation now, you'll notice a problem. The water passes completely through the cloth. This happens because in the simulation solver, there is actually no continuous physical mesh or surface. There are simply individual particles with their respective positions and collision radiuses. Since there is no real surface, the water particles, which are much smaller, simply leak through the empty spaces between the particles that make up the cloth. To solve this and create a continuous physical barrier, we will simply go to the deformable surface section in the Hurricane panel. Here, we will find the surface collision option and enable it. It is important to understand that the properties in this panel act on a global level, coordinating how different materials and solvers interact in the scene. Under the hood, this option reconstructs a continuous surface using the coordinates of the cloth particles and projects the fluid outward to prevent it from slipping through. However, if we press play, you will see that the water still leaks through in some areas. This happens due to a mass imbalance. We have thousands of heavy water particles pushing simultaneously against only a few cloth vertices. When so much fluid weight accumulates on the cloth, the solver is overwhelmed and allows the water to pass through. To fix this, we just need to balance the masses. We'll decrease the fluid's mass to 0.5 and increase the cloth mass to 5. These values can of course change. We simply must adjust them until we get the result we want. Keep in mind that altering the emitter masses can directly affect the physical behavior of the fluid or the cloth due to solver's constraints. Therefore, we must stay alert to the visual results and adjust accordingly, though we can always find a good balance. This way, the cloth gains the inertia needed to hold the water and the fluid slides off realistically. To give our scene a final, dynamic touch, we'll use a very useful tool called Unpin at Frame. This option allows us to deactivate a cloth pin at a specific frame during the simulation. While there are other more dynamic and complex ways to deactivate pins that we'll explore in future tutorials, this is ideal for starting out. We select one of our pins and set it to unpin at frame 150. We clear the cache, and when we play the simulation, you'll see that once it reaches that frame, the cloth releases on one side, reacting realistically to the accumulated water weight and falling organically to the ground. To finalize our simulation setup for rendering, we'll generate the meshes of our elements. We'll go to the Surface section in the Hurricane panel, where we have a selector to choose the type of mesh we want to create. First, we choose the Cloth option. A list of available emitters will appear, and we'll select our cloth emitter to generate its mesh. After that, we open the Mesh Creation menu again and select the Liquid option. Here, Hurricane allows us to select multiple emitters in case we have multiple fluids in our scene. We'll make sure to uncheck the cloth emitter to leave only the fluid sphere active, generating a clean and well-defined liquid mesh. And we now have our scene ready. We have combined fluids with cloth using pins, deformable collisions, and dynamic unpinning. Remember that on the official BeFX Studios website, you'll have all this detailed explanation in writing to review whenever you want. See you in the next video!